Hello everyone. Everybody can hear me? Great. So my name is Harish Doddi. I'm the CEO of Datatron. Um, we are doing a small collaboration between Redis Labs and Datatron. So today's talk, I'll focus a little bit of what we do and how the collaboration works a little bit, and some sample use cases. So our team comes from a background where we have worked at places like Twitter, Lyft, Snapchat, built things from scratch in all these places, and have a lot of experience when it comes to handling historical data sets, streaming data like Redis, and trying to build machine learning on top of that. Today, for the sake of the conversation, I'm going to talk about machine learning and Redis part with a deeper understanding of what we do in the machine learning part. So I don't know if you guys have read this blog. There was almost like a month back or 2 months back, we have a blog post that says productionizing machine learning with Datatron and Redis. Did any of you guys ever read it by any chance? This blog post primarily talks about how we use Redis internally at different places of our stack, as well as how our customers use Redis primarily for the machine learning part. I'm going to send you a link anyway towards the end of the presentation so you guys can have a look at it. So let's first try to understand what we do. Primarily what happens is today, I guess most of you are engineers, I suppose. But if you have data science team in your organization, your data science team, engineering team works towards productionizing models. Unfortunately, this process is very hard today, and it's very manual. What we provide as part of our Datatron platform is like the supercharging catalyst, so that we can make the existing collaboration between the teams much more effective by taking a lot of the manual part into something automation. And that's what we do. So what we provide is a machine learning model lifecycle management platform. And I'm going to talk about the model lifecycle, what it means. And what it provides is facilitating the productionization part of machine learning models. And how do we do that? We automate primarily 7 steps: feature engineering, model training, deployment, testing, monitoring, debugging, and management. And this one is for models at very large scale in production. I keep saying the word production, production, production. I'll explain it why that is very crucial here. So the ROI perspective, we try to make more productive from the team's point of view so that you can iterate faster. So if you look at today's enterprise data science lifecycle, it can be broadly classified into 3 phases. First is a development and discovery. This is where your data scientists are working with logs of data, historical data particularly, trying to take dumps on their laptop and everything. And they're doing all this analysis, experiments, models. At this phase, it's pretty much the data science once they have access to data scientists. There won't be any engineering or anything that gets involved. Once you find something interesting, you want to productionize it, because there cannot be any monetization value associated in discovery. It's like you came up with a model that's 70% accurate. What does that mean? That doesn't mean anything, actually, unless you take to production and see it for real. So production is the phase where data scientists will have to collaborate with engineering teams like you guys, and maybe even DevOps, IT teams for provisioning and all that, to make things real. Optimization is the phase that once you have your first model deployed into production, can you do better? Can you iterate on top of that? And this is where scaling, for example, how do your machine learning models scale for largest number of requests per second or something like that? Similarly, how can you bring streaming data into your model so that you can take decisions at runtime rather than static decisions? So all these things will play into picture. So primarily at Datatron, we are trying to focus mostly on the production and optimization part only. not on the discovery. So you guys have plenty of tools in discovery, Jupyter notebooks, a lot of like other important commercial software and all that. That's okay. We are more focusing on the production and optimization part only. So the best way to actually explain, like how we work is actually trying to show a live demo, and that's where I'm pretty sure that you guys will have a lot of questions for me. So why don't we actually talk a little bit about one use case end to end, and then talk about how Redis can be used as a data source, and then talk about the blueprint and all those things. So let's actually quickly go through one simple use case as a demo. So in this example, we are working with a ticket vendor. Primarily, the idea is that if you have, let's say, tickets to a game, today you can determine the price and you can sell it, and the vendor takes a cut and all that. But what if you want, because you have historical data of all the tickets that got sold, you also have real-time data of how hot the game is. Can we use this and come up with something interesting where the system can recommend a price to the end user, and it can be a better decision? So here is a simple pricing model that that's built on top of Datatron's platform. And what it is trying to tell is that in the next few hours till almost a day, which tickets are more likely going to be hot or more likely going to be pricey. And this can be factored in. It's not just about the view of the stadium. That's a separate thing. That's not what we are saying here. It's about what tickets are there, what tickets are left, and what tickets are more likely getting sold quickly. So it's purely dependent on data. So supply, demand, all these signals. On the right-hand side, we are showing you performance metrics. Primarily, when you have models in production, one of the things people do not track is that how well is your model running? That will be the question. Because you must have trained the model at the best performance, but note that your data behavior changes. So how do you need to always make sure that your data actually is in alignment with the model. And here is where we are just tracking some things where the dotted line is what the model predicted, and the solid line is what actually happened. And there is a delay, because you try to predict 6 hours ahead, 24 hours ahead, and after 24 hours, you'll get the reality data. And what you're trying to do is a comparison of how you're far from the reality. Obviously, ideal case is it should just align with it, but that's not going to happen. It depends upon your model. Now, this is where your 80% accurate, 70% accurate really comes into picture. Now, let's try to understand how this model got built on Datatron's platform. So on the back end of Datatron, we have a web UI interface, which is usually used by your admin. And this is where, once we install the software, you get an application that you can start playing with. There is a concept here called Workspace. Workspace is very much analogous to a business use case. Inside a workspace, we have a canvas or a drawing board that actually facilitates you to build your model end to end. So for example, there is a collector of how the data is coming into your system. What is the data that your model is using? You can use different types of collectors. Here, we just set up a simple S3, Amazon S3, but you can use different types of collectors here. Even like Redis being one of the collector here. So once data comes into the system, the next important step in machine learning is feature engineering. This is where your data scientists have done a lot of experiments and came up with the best features for this model. But it's your job to actually facilitate the productionization part. Here is where we inspired from Airbnb's Airflow to build something like this, but more focused on machine learning part. This is a machine learning model workflow that tries to understand your historical data and convert to something useful for the model, because your raw data cannot be used by the model. So here is where let's just see one node. On the left-hand side, you can see that we can connect to your GitHub. And on the right-hand side, it's pretty much your data engineer is giving the code on how the historical data is getting converted. Here is where I wanted to tell you 2 points. One thing is models operate in a very virtual environment. So often your models, they are dependent on a TensorFlow version something, or they are dependent on another specific version. And your models won't work unless you create that virtual environment. So we automatically do that, for example. Once you have the features ready, there is a trainer, which is where your data scientist code comes in. Here is where, if you already, as I said, if you already have existing development environments, you can just bring them in, or you can use the GitHub to upload your IPython notebooks from your data science teams. Once you have training thing done, you actually can use real-time data. And the real-time data is depending upon the use case. For example, pricing, you want not just historical data, but also real-time data. An example is that, let's just say that there is a concert happening. Typically, historical data won't capture that because the concert need not necessarily happen on the same day, same time, and all those things. But if you just use historical data, you're probably leaving money on the table because there might be demand for the concert. So how can we take both historical data and real-time data and then take a decision is where the impact on the revenue comes in. Finally, your model is pretty much available as an API endpoint that you can query with a payload. And this payload can be used, determined at the runtime, and it can be used by different requests in a different way. Now, once you have all these models done, here is pretty much like we are just calling the model API. Very simple, nothing fancy here. But again, the front end can be anything. It can be any internal application or anything like that. Now let's talk about how this can be used in the Redis context. So usually with Redis, there are 4 places that we see how is part of our stack, plus also some of our customers. Number one thing is, typically your data is present in the data that you use for your analysis for your models is typically from the data lake, which is like a Hadoop cluster or a Teradata cluster or something like that. But these days, the trend is changing. The new trend is, yeah, you have data in the data lakes and all that. Can I use the most recent data also? And this is where you and your competition can be differed, because you are taking better decisions and your model is adapting. So number one way is Redis as a data source directly. So if imagine that you have like last 5 years of data sitting in a Hadoop cluster, but you have last 1 month of data in Redis cluster, how can we use it? Once you have data coming in, there are connectors that we provide and all that, but primarily we are trying to get data into our platform and do the machine learning part of it. The second place where Redis is used is in the serving part. Serving of the models. In the serving of the models, depending upon your performance, what performance you are expecting, that's very important. So for example, in the stadium graph that I showed, we use a technique called pre-computing. Because whenever a request comes at runtime, you want to give it very, very fast in milliseconds. And often, if you don't do that, you will be timing out the request because you're computing so many things in real time. So imagine that in a stadium which has like 10,000 seats, we do pre-computing on each seat, the score, and we push it into Redis cluster. So at the runtime, it can be used as a cache. So whenever a request comes for a particular seat, you just do a lookup. But the processing can happen offline, and it will be on a continuous basis. The third place is that Redis is an ML data type. This is where often you may have things like, I don't know, location-wise geohash, for example. How you want to do scoring by locations. Imagine that San Francisco as a city, you have like probably like 20, 30 zip codes. Usually that's not enough for to build any machine learning model. You want to go at a granular level, like a street level or a block level. Then only you'll have more data points to compute. Now, what typically happens is that when a request comes, imagine like, you are a ride-sharing company, for example. They can open the ride-sharing app at any location. You don't have any control. But wherever location they open, you want some sort of hashed key that you want to look it up and then like grab it. Because if you try to compute these things like, okay, what is the latitude, longitude, and then how do I convert this, and then look for the model, it'll be too late. So imagine like you closing the ride-sharing app quickly and then going off to another competitor. So Redis ML data type is where we believe that you can have some sort of hashing on the user ID or on the user ID plus location or on the user ID plus location plus time. It can be anything. And it can also be aggregated because when the request that you come, sometimes it can be like minutely, sometimes it can be hourly, daily, monthly, and so on. So you, as you aggregate, as soon as you have these things, you can aggregate it. And the second part is that Redis has a nice expiration feature. Typically, your models, when they get rebuilt, let's say every day or maybe once in a week or something, lot of keys need to be automatically expired because they are computed on the previous algorithm. And Redis ML data type has that feature of expiration, setting expiration, TTL we call it, that facilitates these things. So the idea here is that if you can like come up for this business use case that you're working on with your data science team, if you can come up with a hashed way of keys, or if you can come up with a expiration timestamp, it's better to use Redis ML data type than anything else. The last one is actually streaming. And streaming is very, very important because I was telling you that typically most of the models are built on historical data. But if you use streaming as a data source, you want to take a decision at runtime. And the runtime decision can be dependent on historical data where you have already pre-computed weights and all those things. But on the streaming side, you won't know until the request comes. So I'll tell you an example. So imagine that for the ticket vendor company, they have known that historically tickets are getting sold for this particular seat at like $20 or $30 maybe. Now that's good, but let's just say that somehow through real-time data sources that they have, whether they're storing in Redis or not, they found out that certain player got injured or something like that, and he may not play in that game. For some reason, suddenly the game hotness will either increase or decrease. You don't know. Now, if you just use the historical data, which is the batched version of the data, obviously you're taking a decision saying that, oh, historically this is like this, so let me just take this. The problem with that is, if let's say the game is becoming hot for some reason, and you won't know it until almost close to real time, you are probably losing the revenue opportunity because there is a possibility that you can actually quote more because of the demand. And also, on the other hand is, if the game is getting not that hot or like very cold, you're quoting too high price. And that's where like the problem comes. So, and the thing is that today, mobile phone is being used pretty much everywhere. And there is a lot of data that you can get from your IoT devices, from the streaming part. Now, the idea here is that, as I said, you can use your streaming data and learn on the fly with the model. And the model need not be redeployed every single time. So the final part is that, as I was saying, that if your data is residing inside Redis or not, considering streaming data into models is very important. And we have seen significant results there. Sometimes like the revenue jumped by quite a bit, because we are taking a decision at runtime. Just an example here for a use case that we are working. Imagine like an IoT device. Typically what happens is Your data center has all the historical data. And what typically happens is that people try to take dumps of the data, come up with a model, and train it, and then they have a finalized model. They try to ship the model onto the IoT device, typically. But the problem is that IoT devices now have very good compute power, but they also have power to stream data. Now, as this data gets streamed on the IoT device, not on the data center, the model is not learning because you're not considering that as part of the model. So your model is only as good as what the data it has been trained on. Unlike them, if we come up with Redis as a streaming data source on the IoT device, we can actually merge the streaming data plus historical data. So once we deploy the first model, the model can learn from the streaming data. And you can configure these things, like however you want, the weights and all those things. So the idea here is that the model can learn faster. Because what you see, and once the model learns from the IoT device, you can actually ship back the learnings to your data center. That will be huge because whenever you build a model, you come up with some assumptions internally. And your assumptions may or may not be true, who knows. But once you collect the data on how the model is behaving when it comes to IoT device and you ship it back, you can correct it. It's called course correction in AI. So this is another example I was telling you of using Redis as a database. Primarily, data lake would be the most general source for building all these models. So this is a simple example where we are building a fraud model. Fraud models, typically, they are built over a period of time, like 1 year back, 1 year worth of data, 5 years worth of data, 10 years worth of data. The problem is that fraud models, the data that they are consuming today is purely historical. But if you want to bring in the power of streaming data into the model, and as I said, like take decisions based on both, that would be much more helpful. Because the problem is that if you have just the static way of doing things, the models, unless you redeploy, and data typically takes a lot of time to come into data lake, you cannot do much on the fraud model. But the idea here is that if we build a model on the historical data source, can we connect the real-time data sources? Or when I say real-time, like most recent data sources. Then imagine that your model, just like relying on old data, it can consider both old data and the fresh data and keeps on updating. Because typically your data scientists, they are purely dependent on the data lake. But you can give them unlock them the power of the data source directly. So the idea here is that imagine that you have a credit card transactions company. Once let's say that you have built a model, you shipped it, the model says a particular transaction is fraud. But let's just say that somehow there is a support team or something like that, and they said that this is not fraud, by the way, because of blah, blah, blah reason. Now, unless you redeploy this model, the model, again, you come back, it will just say it's fraud. So that's where like bringing in like some type of feedback loop also helps as part of storing that feedback loop data in Redis or anything like that. I think I can take any questions actually, because I want to make sure like you guys are following. Yes, please.
Where does the model reside?
On the client side or on the?
Right, yeah. So, and also trying to picturize what's the role of Redis ML here?
Yeah. So in this example, the model is residing as a simple file on the IoT device. It's up to you whether you want to create like a modeling environment, productionize, that's dependent on the customer. But you need not be. You can just throw the model as a simple file into the operating system there. That's one way. The second thing is Redis ML data type here is being used locally. There is no connection to the data center. So the pre-computing and everything, we are doing it ahead of time. So all that we are doing is just a lookup for the key and just looking up and taking the output. That's it, simple. Any other questions? So the historical data, so the question is how big is the data? So the historical data can be in the order of tens of terabytes to hundreds of terabytes. And the real-time data we have seen is in the order of 1 gigabyte per minute to almost 10 gigabytes per minute. And that's like a lot of data actually. And the real-time data, as I said, right, it can be coming from your Redis database, or it can be even like other sources, like your mobile devices. They generate a lot of log. Similarly, your websites, they generate a lot of log information. Any other questions? Yes. Sorry.
Can support any type of models?
Yes, Datatron does. Yes. Our platform supports any type of models.
From anywhere?
From anywhere. I think one of the, does anyone have any machine learning models that they're already working on today? You have it, okay. So what could be, maybe you guys can tell us like any challenges that you guys have so that I can answer it.
Yeah, I was wondering if you can describe more in detail what's the mechanism by which it can online learn? Like what's the model type?
So the online learning is actually, I would say it's categorized into two parts. One is getting the real-time data and showing it, extracting the features from the real-time data. And what is that aggregation and all that is determined by your data scientist or by your use case. So typically imagine that you have like an example is like you're generating the log from the mobile devices from all the users. The demand factor can be that, for example, how many people are actually looking to buy a ticket? Or how many people bought a ticket in the last 50 minutes? The idea here is like we're trying to come with a signal from the real-time data. That's one part. The second part is online training. That's a whole different story. Online training, and again, this may or may not apply for your use case. So before you go through this route, first make sure whether this is something that you guys really want, because this is a very difficult part. Online training is you already built a model. You already built a model on the historical data. You get, let's say, incrementally 1 hour worth of data. Can you retrain on that 1 hour extra worth of data? And again, as I said, right, like imagine like the model is like to start off, it starts building on historical data, but as you get more data, it's learning and like rebuilding, learning, rebuilding, learning, rebuilding. This type of architecture is very difficult in general to build. Even at Datatron also, we only support very few algorithms to do this. Not all the algorithms that are available. So the idea here is that unless your use case is so much dependent on online training, because it somehow sees something totally different like a stock market type of thing, then it doesn't make sense. Like for example, a ticket marketplace, hourly is good enough. Not even like going to minutely and seconds. We in the example that I showed, in this example or in the other example? In the other example I showed you, we are actually extracting features from the real-time data stream. And that's what we are doing. Yes, we are using it in prediction. But the idea here is that the score of the prediction, it changes every minute. Because imagine that you have a window of last 1 hour or last 50 minutes. As the window moves, everything needs to be recomputed. Because values change and everything. I think she asked.
Yeah, I don't know, maybe we can talk offline, but I had a quick question that was a bit confusing to me. You said you're going to ship the model. My understanding was the model is actually some kind of algorithm and the data is actually in the data center, right? The data resides in the data center. The model often is some kind of algorithm which then acts on the data. So I was confused when you said you ship the model to the IoT device and the IoT device is then running the model. My understanding was usually you consolidate the data at a central location or some kind of, stream it into a centralized location from where you can actually run the algorithms for, acting on the data, doing prediction, classification, all those things.
So the question here is that, do we need to ship the data along with the model, right? That's not true, actually. So there is usually data, the raw data that you come up with, and you are training the model. Think of it like this. Like, you may have hundreds of terabytes of data, but your model file size is probably 20 gigabytes. It won't be that big, actually, because all that your model is doing is, think of it like a matrix of weights that you're operating. You don't need the original data, because once you train the model, your file is the model file, and that's what you'll be shipping to the device. And that doesn't need all the hundreds of terabytes of data. Yes, yes. Yes, because the IoT devices, they collect live data. Like, imagine like you are passing through the tower, it's generating some logs that so-and-so user is passing through the tower. That's what I'm trying to say. And it's very difficult to put hundreds of terabytes of data on that device. Yeah, please.
Yes, I have a quick question. I was wondering, is it possible to, I guess you could say, schedule the actual, when my model is retrained?
Yeah.
Like say instead of, kind of like every 30 minutes, maybe every hour, maybe you might do this every 24 hours.
So the question is that, is it possible that you would like to know when the model needs to be retrained? Is that what you're saying?
Yeah, I mean, basically, you might have like different types of properties that you may want to like initiate like a new training. For example, like say if I want to basically retrain my model for every, I guess you can say, million inputs.
Yeah.
Or basically 2 million inputs. Or basically, or you can base it on like maybe an hour.
Yeah.
Or basically some time.
Yeah. So that's a very good question, by the way. So the question, I'm going to repeat it. We have deployed models and all that, but is there some way that I can know that, is this model need to be retrained, like, because this is going through? So this is where we are actually going into a concept called, in machine learning, called concept decay. Every model goes through a decay factor, and this decay factor will be dependent upon your use case. Nobody can determine what would be the decay factor. But there are tools that are available through Datatron or through some other stuff too, where you can configure what is the decay factor, concept decay. And typically, the way it works is that when a model is going through a decay factor, and one example is that, let's say that you are showing a price in this ticket example to 100 users. Historically, out of 100 users, you have confidence that 50 users will likely convert. But for some reason, in the last, let's say, 5 hours, or in the last 8 hours, you're showing it to 100 users, and you have conversion rate of 5 users. There is something wrong with the model. So that's very, very important, because the reason why model decay can happen is many, many factors. It can happen, why that is the case. So all that we can do at this stage is to try to put guards at different places of your model, so that when your model is decaying, at least you know that there is something going on. And if you don't have this model decay, if you don't monitor it properly, there is a possibility that you will lose tens of millions of dollars in case. Because I have seen it, actually, that we lost like some money and all that in my previous companies. But that's a good question. Thank you. I think someone asked from here.
So you mentioned something about not needing to redeploy the model when we're doing, online learning, for example, because
Yes.
sometimes model training is an expensive process which takes a lot of time, and you would want to factor in whatever is the latest data stream that is coming in while executing that model. So
Yeah.
were you alluding to somehow combining the trained model on historical data with another model that is getting trained in a streaming way, and you combine them to make the prediction results, or was it something else?
That's a very good question. So the question is that we have historical model built on the historical data, but is there a model that can be built incrementally on the streaming part? And that's a very crazy idea, very good, but we don't do that, and I don't think that makes sense also in general in the data science space. The way we do is that we build a model on the historical data, but when we want to rebuild, there are two parts, two ways we can do. One is, let's say you built a model on 1 terabyte of data, and now you got, let's say, 100 gigabytes of data. It's technically impossible to apply something on 100 gigabytes of data on what you have trained on 1 terabyte. It's technically not feasible, first of all. But let's just say that you build a model of 1 terabyte, and let's just say that that came to 10 gigabytes of size. Now, it's, at the end of the day, model is nothing but it's a bunch of weights, that's it. When you get this 100 gigabytes of data, if you do online training, you need to merge the whole data set again. Because whatever the 100 gigabytes data that you contributed has impact on the 1 terabyte of data, most likely. And that depends upon your use case. May or may not be, I don't know, but it depends. But your 1 terabyte data is changing because you need to recompute a lot of things. Now the other part is the, of the online learning part is on the features part. In your 1 terabyte of data, you have, let's say, 5 features. But you also have another 5 features coming from the streaming data. Now, you're technically not rebuilding the model, but your model is in such a way that it got trained that it has weights from the historical plus weights from the real time. So the computation of the final score is dependent on runtime. There is no pre-computation there. Make sense what I'm saying?
It makes sense, but so what you're saying is still at the end, it's just one model which is out there, and
Yes.
when we get that,
Yes, it's only one model at the end of the day.
Right.
Now, we are right now working on one of the improvements here that we found, as part of our secret sauce anyway, is when you have a model that you built with the one terabyte, when you get like new data, can we do something on that? That's like work in progress. We don't have it yet, but we know how to do it. Yeah. All right, I think that's pretty much it. Oh, sorry. Yeah, sorry. Okay. Okay, thank you guys. Thank you so
Thanks
much.
everyone for joining.